Good morning, everyone. I hope you guys are having a good start to your day. We have an exam on Monday. So what I wanted to do is give a little bit of a review and give you some previews and maybe some thoughts about how I'm writing the exam and how you can kind of divide up the material that we covered. Um, the first thing is that the first thing is that the exam is going to be roughly 33. Oh, oopsies. It's going to be 30 questions. I'm recording. Okay, good. 30 questions, 10 questions with old stuff, and then 20 questions with our new stuff. Now, I just got a question about, do we need a code, a entrance code? Just like last time, the Proctorio administers the code. And so you do not need a code, but instead Proctorio, provided that you have that installed and it's functioning properly, that's what's going to um, basically input a code. Now, I think that we probably need to talk independently because about Proctorio if you continue to have problems, but that's a more of an independent thing. So we'll sort that out, okay? Okay. Um, so your exam is going to be 30 questions, 10 with your old stuff, 20 with your new stuff. And your old stuff, good question is, how do I study for that? What old stuff do I look at? Well, the way that you do that is you look at your old exams or your old exam and look at those questions and ask, go through those individual questions and say, why is this one right? Why is this wrong? And so this is the best source for you to look at to put together questions that relate to the old stuff. The reason being is because the way that we're grading, or the way that I'm grading this class, is as we learn new material, it kind of compounds. So what that means with respect to grading is your exam one grade, your exam two grade. I'm just going to limit this to exam two and your final. In the grade book for exam one, you have the score that you got on exam one. So let's say that you got a 75 on that. There's going to be a total of three grades that are input here. Exam two is going to be considered your second attempt at exam one. So let's say you get a 90 on exam number two. Your final exam is going to be your last chance to replace exam one material. And let's say that you get an 85 on the final. What that's going to lead to is dropping the 75 and 90 when it comes to calculating the like 12 per or the 15% that accounts for exam number one. So that's why we have old stuff on this exam because it's all kind of cumulative. Now, new stuff. Will the first 10 questions be from exam one? Um, yeah, they're gonna, I believe that they will. I believe that the sequence of questions does not get shuffled from what I input. So, yeah, chances are it's going to be the first 10 questions. Yeah, I'm recording good. Okay, so then that brings us to the next 20 questions. The next 20 questions are, well, how are we going to divide that up? Okay, just as a little bit of a refresher and a review of what we've gone over since our last exam, and to give you a sense of like, what do you have at your disposal? Well, since our last exam, we talked about ions. We talked about common ions. Then we talked about bonding, different types of bonding. And we use this bonding to talk about ionic bonding. And then we spent a day talking about covalent bonding and then reviewed our different types of bonding. Now, when it comes to bonding, that's a question of basically, do two atoms share electrons or does one atom give up electrons? If the electrons are given up, then we are talking about an ionic bond. If the electrons are shared, whether that's evenly or somewhat unevenly, that would be considered a covalent bond. Now, you have the PDFs as well as the PowerPoints for all of those. In addition to that, the recorded lectures. Now, those are all great resources to look through. I understand that the lectures are, that's 40 minutes and you've already spent or that's 50 minutes. You've already spent 50 minutes. So if you're like, oh, what should I do? I would go after the PDFs first. And then if you're like, I'm looking at this slide in the PDF, but I can't really remember what was talked about, then go to the YouTube link and click and drag or scrub through. Do we have any exam guides for exam number two? And we have to read all slides from exam one? Prirana, that's a great question. With respect to exam two, um, I believe that I have that posted. If it's not posted, then that means it's not published, and I will make sure that it will be. Um, as for slides for exam one, I would not necessarily do that. I would go after exam number one and make sure that I have those the questions from exam one. That's where I would focus my study because the way that I write an exam is I'm like, okay, well, this is important material. I'm going to write a question about that. So I was already kind of gone through like a filter of sorts. Then for a bonding review, that was where we talked about ionic and covalent bonding. So if these three topics are something that you're like, I feel decent about, but I just want a little bit of a refresher, I would watch this link. That's going to be a summary of all of these different topics. Then we got into molecular shapes. We talked about molecules, their shapes, and drawing Lewis structures. Now, when we talk about molecular shapes, we're talking about basically positioning of different atoms. And there's special names for all of those different structures. We then went into molecular shapes with lone pairs of electrons, and then molecular shapes without lone pairs of electrons. So this was a lot of, hey, here's a molecule. Do we have a specific time or a time we have to take the exam, or is it open all day? Just a second. The molecular shapes with and without electrons is basically here are the elements, and here are the shared electrons, here are lone pairs of electrons. Now, for the exam, last time I had it open fairly late, and I'm not going to do that again because people were running into problems at like 7 p.m. So, what I'm going to do is I'm going to have the exam open from our class starts at 10 a.m. So, I'm going to open it at 9:30 and I'm going to close it at 6 p.m. So, with respect to all day, you have the working. Yes, you do have most of the working day available, but I'm not going to have it open until 11 p.m. because that was kind of problematic. In the event that you need something else, please don't hesitate to contact me and I will work with you. But 9:30 a.m. until 6 p.m. And again, if there's something specific for you, please email me, and that's the best way we can set up a communication because that's not for everyone necessarily. Okay, so this figure, I kept going back to this. This is a very important figure because this shows the valence electrons that every atom has. Now, valence electrons are something that, yeah, like I said, every atom has valence electrons. Does anyone remember what are the valence electrons or which are your valence electrons? Another way to describe valence is to describe them as your outermost electrons. Those are the ones that are farthest. Josiah, perfect. They are outermost, they are farthest from the nucleus. Now, if we take, for example, um, fluorine, does fluorine have, and these are two different questions, but does fluorine have seven valence electrons or does fluorine have seven total electrons? And the answer to that, it has seven valence electrons. How many total electrons does fluorine have? Now, to answer that question, you'd have to look at the periodic table. And I'll give you the periodic table. But fluorine has a grand total of nine total. I'm going to say nine total electrons. But Josiah, you're absolutely right. Seven valence electrons. So that's an important distinction. So make sure that you know the difference between your number of valence electrons and your total number of electrons. Because I might give you a question, or chances are I'll give you a question like that, in part because we saw questions like that right here, for example. This was a question that we had as a Zoom poll. How many dots surround Br and the Lewis dot symbol for Br minus? Okay, so I'm going to jump back to that. Now, that question was about Br minus. That question was not about Br. It was about Br minus. What does that 1 minus indicate? That indicates, or this right here, that negative symbol is the same as one electron. Perfect, Kevin. It gains an electron. So Br has seven valence electrons. It's in group 7. So how many electrons surround Br minus? Or how many valence electrons surround it in that Lewis symbol? Close. We're going the other way. This is one thing that people fall into a trap on. So Br right here, it's got seven valence electrons, but Br minus, Dylan, absolutely right. It has eight electrons around it. So Br minus, that minus symbol, this is where it gets confusing because the charge of an electron is -1. So when you add -1, ooh, it gets hairy. But remember, we're adding one electron to a total of seven electrons. So that means we're a total valence electrons of eight electrons. So that question, what you might see is, I can give myself a blank page to write on. I could ask a question like this. What is the correct Lewis dot symbol for, let's go with O2 minus. Okay. So I'm going to give you four different options. And I like to take the time to write all these options out so then you can see different options and why they're right and why some of them are wrong. Okay, so all of these Lewis dot symbols are going to have oxygen. Yeah. Okay. Now, in order to answer this question, you have to know that oxygen has six valence electrons. So I'm going to give you 1, 2, 3, 4, 5, 6. That's one option. Another option would look like this. There we go. Actually, let me erase that for a second. Yes, you can use a note card on the exam. And I will ask that I'll give you an ungraded assignment where you have to submit a picture of your note card. Okay, so there's that. Then There we go. You're going to submit the note card after the exam. Okay. So which of the following is the correct symbol or Lewis dot symbol for O2 minus? Josiah, you're absolutely right. Corazon, you're right as well. Great job. The reason is because I have two additional electrons. So you have to know and look at the periodic table and see, okay, oxygen is in row six, so it has six valence electrons. When I see that two minus, that means it has two additional. Now, if we look at answer option B, Caitlin, that's a fantastic question. Typically, what they're going to do is, or typically, whenever you draw a Lewis structure, you're going to kind of pick one on each side or place one on each side and then place a second, a third, a fourth, and or sorry, fifth, sixth, seventh, and eighth. So it does definitely trend in a like clockwise or counterclockwise fashion. Um, but in terms of for this class, what do you have to know is like I think that maybe what you're asking in part is would I give you answer option E like this? No, I would not. Or sorry, I mean, that wouldn't be right, but I wouldn't ask you which one is right, B or E. I wouldn't ask that sort of question. The convention, I think, is to start at like the 12 o'clock position, if you think about the face of a clock, and go counterclockwise, putting one electron in at a time. Absolutely. Thanks for the question. That's a great question. Okay, so this, to me, this is a great question, and you'll absolutely see a question like this because it requires you to know Lewis dot symbols. It requires you to also know about ions and what makes them unique. Now, a way that I could make this question pivot is, and make it a different question, is this. Okay, what is the correct Lewis dot symbol for O2 plus? Okay, so 2 minus, I had two additional electrons. Well, O2 plus, that's a little bit trickier. What do you guys think that one is? Okay, oh man, okay. Now you guys are just, yeah, showing off. You're absolutely right, though. This is B would be the correct answer because I know that oxygen has six valence electrons. In order for it to have a 2 plus charge, that means it's not going to have two of those electrons, two of the six. So it would only have four electrons surrounding it. Great job. Great job. So this question right here is kind of what I would classify as like a second tier question. So second level question, because it's taking other information and putting something, a more complicated answer together. Now, if we can jump back, looking at this right here. If our question, or sorry, let me clear all that up. And then our exam is going to be 20 questions of new stuff. Okay, so these three lectures are new stuff, and these three lectures are new stuff. They're all kind of tangentially related to one another, but I would say it's pretty safe to bet that there's going to be 10 questions related to this and 10 questions related to this. Now, all of these things, they're not really independent. It's not like I'm asking you about, you know, Texas history for one block, and then the other one I'm asking about, I don't know, submarine manufacturing or anything like that. These two things are pretty closely wound together. Why I say that is because this slide right here, I think I showed this on all six or maybe seven of our lectures, where we looked at what are the different numbers of valence electrons on all of these atoms. Now, I'm not going to give you this slide. I'm not going to give you this figure. I'm going to give you the periodic table. So what you need to do is take the information that's on this figure and be able to look at a periodic table and extract that same information. Know the boundaries and know basically how many valence electrons or how many electrons are around every atom. Now, I'm going to give you that because this will be very helpful. Um, or sorry, I'm giving you this now. This is not going to be on the exam, but the better that you know this, the better off you're going to be when it comes to, answering so many different questions. Now, there are some pieces of terminology. The octet rule. The octet rule states that atoms tend to gain, lose, or share electrons until they have 8 valence electrons. So 8 is the desired number of valence electrons. So when we talk about like common ions, what's the common ion that oxygen likes to form? Well, a way to process that, and I'm guessing that some people are ready to type in their answer, which go for it. The common ion that oxygen likes to form, well, oxygen typically has 6 valence electrons. So how is it going to get to 8 valence electrons? And this is one of the places where it gets tricky. It's going to get to 8 by adding 2 electrons. But the way that we denote that is by writing 2 and then a minus symbol. 2 negative. It has 2 additional electrons. So that's going to reflect the octet rule. Okay. Have a good one, Zyler. I'm going to record this and I'll post it on our Canvas page. If you have any questions that surface, just shoot me an email. So this is what atoms are typically going to do. Now, they're going to form specific common ions, sodium ion, Na+. And there's terminology associated with this. This right here is the sodium ion. Add to the chat what the name of Cl- is. I'll get you started. It's the blank ion. Fill in the blank there. Chloride. You're absolutely right, Caitlin. It's the chloride ion. It's not the chlorine ion. So that IDE suffix is an important suffix for you to keep in mind. So that's unique. So the IDE suffix is unique for nonmetals. So when it comes to bonding and different types of compounds being formed, one of the other things that we talked about were polyatomic ions and naming compounds. When it comes to um, covalent compounds or covalent slash molecular compounds, we talked about using prefixes. So mono, di, tri. So for example, what is the name of this compound right here? Yeah, add that to the chat or say it aloud. Carbon monoxide. Now, both carbon and oxygen are nonmetals. So that's an example of a covalent compound. We say carbon monoxide, despite the fact that there's only one carbon and there's only one oxygen. We only use that mono prefix for the second element. Now, what is the chemical name for, we think, I'm going to give you, well, we'll go with one right here. SF6. What is that compound? Close. You're very close. The only thing you've got the IDE. IDE is right. There's only one thing that's missing. Think about, we called this carbon monoxide. How many fluorides are there? There's 6 of them. So we need to use a prefix. what's your prefix for six? And what I always like to do is I like to think of shapes. If you're in the Ultimate Fighting Championship, yep, hexa. So it is sulfur hexafluoride. So you've got to have that prefix there. If this was, now let's go ahead and try this one, SF5. What's that? I'll give you a hint. It's very similar to the sulfur hexafluoride. What's the building in Washington, D.C., where lots of government employees work that's named after a shape? Spoiler, it's not the White House. Sulfur pentafluoride, that's absolutely right. Okay, so prefixes, we use those when we talk about covalent or molecular compounds. We do not have to use them when we talk about ionic compounds, sodium chloride, for example. Now, that's all relevant and that's kind of interconnected to basically looking at a structure and putting together a structure and thinking about ions. Now, positive ions lose electrons, negative ions gain electrons. Negatively charged ions have more electrons than they have protons. Positive ions have fewer electrons than they have protons. We talked about this as an example. Then, when you look at a single bond, a double bond, or a triple bond, how many electrons are represented with a triple bond? Six, because each bond corresponds to two electrons. So you've got three bonds, three times two is six. Okay, well, I think that the best thing for you guys to do is I'm going to be publishing a practice exam later today, and I strongly recommend going through that practice exam. And I will make that practice exam available as many times as you want. So you can take it. It's not going to be, or sorry, it's going to be graded, but it's not going to contribute to your course grade. Um, that practice exam will be available until I'll call it, Monday morning at 8 a.m. Um, but that's going to be up for you guys to work on this weekend. What I'm going to do is just kind of open the floor if anyone has any questions. Um, remember, the exam will be open. Actually, I'll open it at 8:30 in the morning and close it at 6 p.m. Again, if you have something specific for you, let's communicate through email or something like that. No, not something like that, but let's communicate by email so we can sort that out if you have unique circumstances. But other than that, what questions does anyone have? Kind of the general questions. Okay, great. Which elements? The only chart we have is the periodic table, right? I will also give you the chart with the polyatomic ions, and that's going to be worthwhile in naming. Then, and I think that's it. Which elements can exceed the octet? Great question, Trevor. The ones that can exceed the octet that we saw sulfur. Basically, sulfur in anything below or to the right and below that is going to be able to exceed the octet. When bonding a metal and a non-metal, is it considered an ionic bond? And sorry, and with that, don't we use prefixes to name? A metal and a non-metal is going to be a ionic bond, and prefixes we actually don't. So if you, as an example, Okay, I'll answer Bella your question. What topics are best to focus on for this exam? The ones that we've covered so far. This basically the 6 days of ions, bonding, covalent bond, ionic bond, and then drawing a Lewis structure, identifying lone pairs of electrons, and then looking at the different molecular shapes. For instance, a bent molecule or a linear molecule. I'm not going to ask about bond angles though. When bonding a metal, and I think that whenever you go through the practice exam this weekend, that will give you a better sense of what's going to be on the exam, in terms of like, okay, I'm good on this, and this. Maybe I need to brush up on this. When bonding a metal and a non-metal, is it considered an ionic bond? Yes, it is. And with that, we don't use prefixes to name it. That is correct. We do not use prefixes. So as an example, let's go with MgCl2. That compound is magnesium chloride. Metal, in this case, is magnesium, and there's two chlorines. The reason we don't use the prefixes is because it's almost like implied. It's a part of basic chemical knowledge. And whenever I say basic chemical knowledge, I mean a chemist's basic knowledge. They know that magnesium is going to form a +2 ion, chloride is going to form a -1, and you're going to have two of them in order for that to be a neutral compound, which is one of the aims and goals of a ionic compound. So you do not need to use any prefixes. Any other questions? Well, if there are no other questions, I'm going to go ahead and stop my recording and I will